Now we're going to address powers of products and quotients together. First thing I want to do here is take a look at this first problem at the top left. You have parentheses 2 times 5, parentheses, raised to the third power. Well, if you do what's inside the parentheses first, 2 times 5 is 10, and 10 to the third power, which would be 10 times 10 times 10, would be 1,000. But I want to see if the following pattern or the following approach might work. What if we were to take each of the parts here that are being multiplied? The 2 is being multiplied by 5, and then collectively that's being raised to the third power. What would happen if we took each of these to the third power individually? 2 to the third would be 2 times 2 times 2, which would be 8. And then that's going to be multiplied by 5 to the third. Well, 5 to the third would be 5 times 5 times 5. Well, 5 times 5 is 25, and 25 times 5 is 125. Then if you went ahead and did the math and the calculations, 8 times 125 is in fact 1,000. Which is the same thing we got by multiplying what was inside the parentheses first. 2 times 5 equals 10, and then we took 10 to the third power, which also equals 1,000. So that opens up a new product for us, a new law of exponents for us that'll be addressed on the review. And that is, anytime you have a particular two numbers being multiplied together, and they're both in parentheses, and then you're raising that product to a particular exponent, you can take each of the individual numbers that are being multiplied together to that exponent individually, and then you can multiply those together to get your answer. So another way of stating this, and I'll put it here in a different color, is that 2 to the third times 5 to the third is the same thing as going 2 times 5, taking that answer and raising it to the third power. With that in mind, let's take a look at this next one. 2 over 5 to the third power. Here we have two numbers being multiplied together. Here we have them being divided together. And in fact, the same holds true. Whenever you have a particular number being divided by a number, and then that entire answer is being raised to a particular power, you can take the numerator to that power and then divide that by the denominator to that power, and it'll give you the same answer. So how would we rewrite this? We would rewrite it as 2 to the third over 5 to the third. 2 to the third would be 2 times 2 times 2, which is 8, and 5 to the third would be 5 times 5 times 5, which is 125. So what is 2 over 5 to the third power? It's 8 over 125, which is the same thing as 2 to the third divided by 5 to the third. Here we have another division problem, but this time with an exponent. So we're not going to be able to figure out the exact answer because we still have a variable left, but take this and using our powers with quotients, rewrite this so that each part, both your top and bottom, your numerator and denominator, both are expressed as an exponent. Well, our first one would be x to the fourth, and then that's going to be divided by 10 to that same fourth power. So that gives us an answer of x to the fourth over 10 to the fourth. Next, let's just take a look at one additional problem, and then I'll finish up this session here. We have 5 times 10 to the minus 2, and then that entire answer is raised to the second power. So making use of our laws of exponents here, since we have numbers being multiplied together and then that entire quantity is raised to a power, we can take each of the numbers individually that are being multiplied and raise it to that power. So then, 5 to the second power is going to be 25. And then that's going to be multiplied by 10 to the minus second to the second power. Well, remember, when we have an exponent being raised to an exponent, we multiply them together. So 10 to the minus 2 to the second power is going to be 10 to the minus 4, because 2 times the minus 2 equals the minus 4. Now, if I were to ask you to rewrite this in scientific notation, 25, well, remember we have to have a number between 1 and 9, or excuse me, less than 10 and greater than 1. So our decimal point here after the 1 has to be moved to the left once. And in order to create scientific notation, when we have to move the decimal place left to create our number that's greater than 1 and less than 10, we are increasing the exponent by 1. Well, here we have an exponent of 10 to the minus 4. So to increase that by 1, minus 4 plus 1 would be minus 3. So the answer to this particular problem of 5 times 10 to the minus 2 and then squaring that entire answer is going to be 2.5 times 10 to the minus 3rd, written in scientific notation. So then on our review page here are the fourth and the fifth laws of exponents stated. Fourth law of exponents says that when you have x times y, two different variables being multiplied together, and that product is collectively raised to the a power, you can take each of the parts that are being multiplied to the a power as well. So, parentheses, x times y raised to the a power is going to equal x to the a times y to the a, with the only limitation here being that a is an integer. And then lastly, in our fifth law of exponents, if we have x being divided by y, and then collectively that answer is raised to the a power, that's the same thing as taking the top, the numerator, x to the a, and dividing it by your denominator, which is y to the a. With a couple stipulations here that once again that a is an integer, but also that y does not equal 0 because you cannot divide by 0. That'll wrap up session 55 on the powers of products and quotients.